I'd like to welcome everybody, and if you would kindly turn off your cameras and mute your microphones. Our speaker today is a very special speaker. We have Dr. Missy Cummings, who is preeminent in the field of automation, human supervisory control, and something that I've been accused of many times, and that is artificial intelligence. She received an undergraduate degree from the U.S. Naval Academy, and upon being commissioned as a naval officer, she completed naval flight training in Pensacola, where she became one of the first female fighter pilots in the Navy. She flew F-18s off of aircraft carriers. She received her master's from the Naval Postgraduate School and then went on to complete her PhD at UVA in systems engineering. She taught at MIT and is now a professor at Duke, where she is the director of the Humans and Autonomy Laboratory and Duke Robotics. So as I said to her just a few minutes ago, if you ever want to feel stupid about yourself, just read her bio. But in spite of that, she's a very down-to-earth person, an engaging speaker, and a great person. I was asking her about her humility, and she said, well, having a 12-year-old is good for keeping people humble, and certainly I can relate to that. So I'd like to introduce Dr. Missy Cummings. Missy, welcome to the NTSB.
Thanks for having me. It's a real honor to be here. I was laughing with you before. It sounds impressive to be a former fighter pilot, but when I think about my 20-something-year-old self, I was so dangerous, so unsafe. So I would be the example of what not to do to be a safe person in my 20s. I think that the good news about that is I did live through that time, so I think I have a lot of appreciation for what it means.
That's lovable. Don't tempt fate. I'm just saying, don't tempt fate.
We just want to remind everybody to make sure that your microphones are muted.
Yeah. I would love to get into a conversation about tempting fate because that's my whole life. But with that, I'm going to talk to you today about some work that I've been doing, both in terms of my research and kind of how it fits in with my world, with my past and my present. And so it's going to be kind of some ideas about autonomous systems, AI, what you should be thinking about, what may be a problem. So you heard that I was a fighter pilot. I flew A4s and F-18s. And so, I think the aircraft carrier, I spent some time on an aircraft carrier, and that's a real eye-opener about what it means to be safe and how quickly, if you are not on top of safety, things can be very dangerous. And so I really owe my career now as a researcher to my time in the Navy. I tell people that the story that people I think like the most is how I knew that I needed to find another job instead of being an aircraft carrier pilot is when I transitioned from the A4 to the Hornet. And when you go on a carrier on the Hornet, one of the things that is most striking to me is that you actually, when you're on the catapult getting ready to be shot off, you have to show everyone around you that you have to put your hands up in the air and show everyone that you are not touching anything. And it's only when everyone's assured that you're not touching anything that they will actually fire you off the front of the catapult. And the reason that you can't touch anything is because in fly-by-wire systems where the computer is controlling everything, you're so close to the stall threshold when you're being shot off the catapult that if a pilot touches the stick, it'll set up a set of pilot-induced oscillations, which can and has led to multiple deaths off the front of the carrier. And so as I was witnessing this and also seeing how computerized and automated weapons, and that we could use Tomahawk missiles, for example, to get targets from over 1,000 miles away, it became pretty clear to me that there was a new game coming. And I decided to get out of the Navy and transition into academia and start researching what it meant to start balancing the automation and the human component in these systems. And this was also motivated by the fact that when I flew Hornets for 3 years, and one person a month for the 3 years that I flew. That's 36 people I knew died flying a Hornet. And they all died, not in a military mission, not trying to, go against the bad guy. It was always human error, and it was always in some kind of training envelope. And so that was a real motivation to me, that the systems were becoming a lot more complicated, that automation meant that people could do maybe more tasks before, but we were also being set up for some danger in areas that we didn't really know what was happening. So I got my PhD. Do not say I got my PhD at Duke. Oh, goodness, the UVA Cavalier, we'd be so upset about that. No, I got my PhD at UVA, hoorah. And then MIT got wind that, I'm one of those rare Loch Ness monster creatures, a woman in automation and AI. And so MIT decided to make me an offer, and I went to MIT for 10 years, and I had a great time at MIT. But then I had a baby, and I decided that life in Boston it was a little too crazy to raise a child. And so now I'm in North Carolina, back in the South, where I'm raising my daughter, who does remind me on a daily basis that I am an idiot. So keeps me grounded. So while I've been at Duke, I became famous in academia for a lot of my work in unmanned aerial systems, what you know to be drones. So I have a really strong footprint in that area, but I knew drones were being commercialized. And when I saw that happening, I needed to get a new research area where, I could really have an impact. And so I was also one of the early people into driverless cars. And I jumped into that space because I knew that there would be a lot of carryover from aviation systems over into driverless cars. And so a few years ago, I'm going to switch our screens now, so just bear with me. A few years ago, then I went and I testified in front of the Senate Commerce Committee, and I'm going to show you now. It's just about a minute of a clip. I'm testifying in front of the Senate Commerce Committee about should we or should we not let driverless cars on the roads. And the person you're hearing from here is Lyft, a Lyft representative, and then I come right after.
Sure that consumers are ready to adopt this. We need to convince them that it's safe, which I think everyone here is committed to doing. And in order to make sure that it is cost efficient, I believe that a ride-sharing platform like Lyft must be involved.
Senator Thune, I'd like to add just one thing, and this is really a critical point. Timing is everything. There is no question that someone is going to die in this technology. The question is when, and what can we do to minimize that? I think.
Okay, so just a brief clip. I'm sorry, I couldn't get it to enlarge. I don't know what the problem is. So this was in 2016 when I decided to tell the world that somebody was going to die. And then one of the things that you might see, if you remember, is that this was in, I think, March of 2016. Then Joshua Brown was killed in a Tesla about 5-6 weeks later. And then, of course, a couple years later, the Tempe accident happened. And so people ask me, they're like, how did you know to say that? Why were you so confident that someone was going to die? And I'm going to give you my secret sauce into how I think about the world. And this was actually a paper that I had published a couple years before that Senate testimony. So you can go read it on my website if you'd like to. But so when I think about the world and I think about who should be doing what, should automation or autonomy be doing something? Should a human be doing something? In the research world, we call this role allocation. So how I think about the world is not in levels of autonomy, not in the NTSB 5 levels, or if you want to do Tom Sheridan's 10 levels, and many of you are familiar with all these levels. I don't think about the world in levels really that way. How I think about it is something called this skills, rules, expertise, what I call the SRKE taxonomy. I am basing this off of some earlier work of Jens Rasmussen, where he had the SRK framework, but I went on to extend it to expertise and uncertainty. So let me walk you through what I mean when I say this. So you see the picture of the cockpit. But he is more of an expert pilot than they are, because he was faced with a set of circumstances that they have not been faced. And indeed, most pilots never face. Tammy Jo Schultz, with the Southwest 737, she is also in that same group with me, right? So we think of Tammy Jo Schultz as an expert pilot, but she is now the expert beyond other pilots because she was able to cope with uncertainty, which is not always the case. So now when we start to think about that balance, if you see at the little balancing triangles at the bottom, where we are right now in the world is computers can do very well as long as the sensors are working. Computers do very well at skill and increasingly rule-based reasoning. But knowledge-based reasoning, reasoning under uncertainty, and certainly reasoning under maximum uncertainty where we need expertise, computers cannot do at all right now. And so we need to think about this going forward when we start to think about, are we going to increasingly automate or maybe have autonomous systems? Because while there are many different definitions of automation and autonomy, and I don't want to get into an argument about that right now, I would tell you that my quick working definition is it's a degree of stochasticity. So automation works under low uncertainty, and as you start, as an automated system has to make more and more guesses about the world, it then becomes an autonomous system. So again, there's no actual clear levels here, it's a degree of automation or a degree of autonomy. And so what I thought I'd do is I'd do some case studies now for you, because to tell you about, if we're starting to think about automated systems that are maybe transitioning to autonomous systems, to first of all give you something that you could walk away with. The SRKE framework that I just showed you, you can go to my website. I've got a ton of papers that go along with this talk. But I also just wanted to give you a checklist. So here's a checklist in the Missy Cummings world from my kitchen, and I'm a Southern girl, so that means I love to cook. So I love to think about, what are all the right ingredients that it takes to have an unsafe autonomous system? So my perspective is that the first thing you're going to have inappropriate role allocation. And so what this means is that balance in the slide that you just saw, that balance is not correct. That a system is designed to maybe have autonomy up in the knowledge and expertise region where it's not qualified to be, or maybe in some cases we've got humans down at the skill level and maybe they shouldn't be there either. And I'm going to give you some case study examples of that. Under inappropriate role allocation, this is where it could actually be two sources of problems. It could be the idea like the allocation is wrong, or it could be the implementation, the design of the system that tried to capture the right allocation, the design ended up being wrong. And I'll give you an example of that later. I think another major ingredient that you're going to need is a lack of internal organized testing. That means that the company does not either know how to test an autonomous technology or just skips it, which happens quite a bit. I'm gonna do Mike's job and tell you if somebody could just mute somebody. Yeah, if muting yourself would be good. Thank you. And then the third big checklist is a perceived financial imperative. And we're going to talk about this later, because I think if people think they're under financial duress, then that causes companies to make decisions that they might not otherwise make. And we'll talk about why. Is it really a perception or is it real financial imperative? The fourth issue, which I know NTSB knows all about because I read all of your accident reports very closely. So we pass around the most recent Tesla accident report. And you're obviously all over this. A lack of regulatory oversight. We have regulatory agencies for a purpose. I'm not saying they're all good or bad. I think regulatory agencies, I've worked across most of them now, and it's very interesting that they all have different personalities. but a lack of that oversight and a lack of even having the capacity to have that oversight, I think is a big one. And we'll talk a little bit more about that. And then, of course, if you just sprinkle in a little hubris and hype, and yes, Elon Musk, I'm talking about you, but he's not the only one. There's a lot of big personalities in this that could actually exacerbate issues. All right, so let's talk about the first one that I know everyone's very familiar with, the Boeing 737 MAX. I like to use this as the introductory case study because I have to wrestle with a lot of people on Twitter over whether or not the Boeing 737 crashed because of its bad AI. And I need to remind people that there is actually technically no AI if you define AI as any kind of underlying autonomy that is making probabilistic guesses about anything. There is computer code, obviously. There are some maybe questionable algorithms and thresholds that were put into the 737 MAX. But the inappropriate role allocation, it doesn't come from the fact that they tried to put in AI, or even in this case, they put in more automation, right? The MCAS as a system was not necessarily a bad idea. The Boeing 737 MAX, it's one where the implementation totally failed, right? They put in the system, they didn't test it enough, which goes to the second point. And then they didn't give pilots the right feedback, either in terms of understanding that it was even in the system, as well as giving indications when there might be something wrong in the pitot-static system. So, people want to argue about whether or not MCAS is a bad idea. The reality is one day all aircraft are going to be flying drones. The question is just, is there going to be person babysitting on board? But I think in this particular case, it was badly implemented and there wasn't enough testing. And it speaks to the third bullet. There was a perceived financial imperative. Boeing had a lot riding on this. They wanted to get this quickly to market. They knew if the FAA knew exactly how much, when people say the Boeing 737 MAX is just a derivative of the 737, later when I come to DC, if you want to meet me in a bar and arm wrestle me over this, I'd be happy to. But the 737 MAX, whole new airplane. That is my perception as a pilot and a researcher. When you're making that many modifications, it's a whole new airplane. And Boeing knew that, and they didn't want the FAA. They didn't want to spend the money for the certification. Arguably, it is a big overhead, but the FAA has done a really good job. We do have low accident rates. And so, there was a perceived financial imperative. The funny thing is, I say it's definitely perceived now because the money that Boeing has had to pay out to fix this problem. It's funny. It's like most things. If they just would have spent the right money at the right time, it may have seemed like it was expensive, but then they would have avoided these longer term costs and also, obviously, the cost to their reputation. The lack of regulatory oversight, obviously a big one in here. I used to be a program manager for the government and for the Navy specifically, and I was shocked when I saw how chummy the inspection process was and how companies would be deemed to have FAA authority. And so, sadly, it took an accident like this to raise that question. But, that is human nature. We do need to revisit those kinds of policies every so often. So when we talk about the SRKE framework, I think the interesting thing about this accident is that it was actually the Boeing 737 MAX was trying to go only about halfway up the arrow. So they weren't really trying to push the knowledge frontier. They were trying to do skills and rules. But because they basically left the pilot out of the loop, and the pilot obviously still needed to be in the loop because of the knowledge and expertise needs, then that really became a problem. And, I think Boeing is really paying for their hubris in spades now. Okay, so let's go to case study number 2. Oh my gosh. The Federal Railroad Administration. I've been working on and off with them over years. Sometimes I just want to pull my hair out because this is a very difficult agency to work with because they don't have the role allocation issue, I think, in their own mind settled. So I say this because they recently, this was a couple years ago, they came out with a proposed rule to force the number of people into a cockpit back up to 2. They had, under some certain operational areas, short haul railroads, they were letting people drop to 1. It's a larger discussion that we can have later, whether or not we should have anyone in the cockpit. I mean, I'm a fan. Rail, on that SRKE continuum, rail is at the very lowest, and we'll talk about that in a second. The more people that you put into a job that do not have enough to do, then you move into this boredom issue. And this is a diagram of boredom, the impacts of boredom on the supervisory control systems, which are transportation systems. And so if you see in the top, what happens is if you've got a monotonous, repetitive, low task loading, mean there's nothing to do, one of 3 things is going to happen. And they might all happen together. You're going to have attention lapse, you're going to get fatigue, and you're going to get boredom. And then if people move into an attention lapse, well, that's driver distraction. And this diagram obviously is all about driverless cars as well, which we're going to talk about in our 3rd case study. But I think this issue of boredom is really important to think about, because if you look to the right side of that diagram, one of the things that happens when people move into a boredom state of mind is that one of 3 things is going to happen there. They're either going to go into task unrelated thought, meaning, okay, I'm supposed to be paying attention. My eyes are on the track or on the road, but it's boring. So I'm going to start thinking about the fight that I had with my husband last night, for example, or wife. Or one of the things that we see a lot in drones are when people get bored, they start pushing buttons and, hey, what does this do? And hey, can I get the system to do this? So sometimes people want to raise their level of activity, mental activity, and they do that by fiddling with the system. That can also be bad, particularly in drones. And sometimes they do that with the system. They'll fiddle with tasks, so that would be increase their own task engagement. They'll fiddle with things in the system, like, oh, maybe what if I redo this nav planning? Or they'll fiddle with some other part of the system that really, they're just trying to keep themselves entertained, and then that has some kind of side benefit or side detriment. So in this idea of putting more people into a cab, you're actually just upping the game, because now there's not enough for people to do. And we've got studies that show that engineers are tasked a little bit, but conductors really have very little to do on the trains. So now you're asking for more and more people to be bored. And and I know that investigators at NTSB know this, just because you have more people in a cockpit, I don't care what transportation system that is, doesn't necessarily mean you're going to have more people catching problems. So when we talk about the SRKE diagram, one of the problems that's happening when we're trying to put more people into a train cab as opposed to fewer, and it's my position we should have 0, that then what's happening is you're forcing people, you're having no automation in here, you're forcing people to attend to skills and rules, but by forcing people to attend to skills and rules in a very low task load environment, then you're significantly increasing the risk that they're going to be distracted or do this other task engagement, leading to other problems. And so the FRA, they need to rethink this. They need to, instead of trying to enforce an increased 2-person in the cab rule, they need to enforce positive train control. Positive train control is the key to the future. And we're still not enforcing it. Even though it's a congressional mandate, we're not doing anything about it. So until we actually enforce positive train control, which is obviously it has major safety implications, but positive train control is the key to automated rail in the future. And this is where the perceived financial imperative is getting the railroads. They don't want to do the capital outlay. They think it's expensive. They whine about how expensive it is to put positive train control in. But again, they're not seeing the forest for the trees because they can't get to fully automated rail, which in my estimation is going to be safer and also much more efficient all around. Until you do that capital outlay, it's not going to happen. So they think that they're spending too much money, but they're eventually going to have to spend it one way or the other. The lack of regulatory oversight is definitely a problem in terms of getting positive train control put in. I don't see a lot of as much hubris and hype in the railroad industry because it's kind of under everyone's radar, curiously. But in all of my research, I have to tell you, the thing that's amazing to me is I still think the robber barons of the turn of the century, from the 19th and 20th century, it's still amazing to me how much they're in charge today and how much industry drives the rail industry, and the regulatory agency has really no dog in this fight. Okay, we can argue about this later. All right, last but not least, you know it's my favorite. You knew I was going to go there, but I'm going to go there in a way that maybe you didn't expect. All right, Tesla Autopilot. I love the car. I'm all for electric cars. Autopilot, scary, dangerous. I kind of half make a joke that if your wife gives you a Tesla and tells you to drive around on autopilot, make sure she's not upping your insurance. You know, this has been a real problem for all the reasons that most of everyone in NTSB knows. If we relate it to the SRKE framework, driving, even at the very lowest levels, driving down an interstate requires skills through knowledge, at least, if not expert-based reasoning. So I think this is, you know, most of the automotive industry did not obviously take my classes and did not listen to my lectures and has not read my paper, because if they had read any of my papers and taken any of my classes, they would know that driving is fundamentally a task that covers all four of these knowledge-based systems. And we just aren't there yet. We simply are not at the place where cars are even close to knowledge or expert-based reasoning. And I'll talk a little bit more about that when I talk about AI. But I have to remind people, these three accidents, the Banner, the Brown, and the Walter Huang accident that most of you are familiar with, these accidents, autopilot was a contributing factor, right? But Tesla has been quite clear about this. And, you know, at least from a legal perspective, they're doing the dodge and weave by saying, look, we tell people it doesn't work. We tell people they have to have, you know, that they're always in control, that the car is not controlled. This indeed is an assist system and it's not a control system. Okay, you know, I agree with that. I agree that they're not claiming that they can do everything on this, on the SRKE spectrum. The problem is drivers think it can, right? Because of using the name of autopilot. And if you want to see my blood pressure go up, talk to me about Tesla full self-driving. But the real problem, the real case study is actually not the autopilot that I want to talk to you about. The real problem is the driver monitoring system. So we talked about the boredom diagram before, and I told you, oh my gosh, you know, humans, we know, and Raja Parasuraman, you know, bless his soul, I was really sorry he was taken from us too soon. He did a lot of really great work early on to show that, you know, once an automated system gets to about 80% of reliability, people mentally check out, which is way too early to be checking out. I mean, you need something like 10 to the minus 6 before you can really check out. And so we know that attention lapses and boredom are big deals when people are not just in Tesla, and I don't mean to pick on them per se, because there are other cars too that have various driving capabilities. But it is this problem is when the car is doing good enough that people check out, and if you don't have a good enough driver monitoring system to check them back in, then you're going to have a problem. And I still have, you know, I have driven most cars with some kind of driver monitoring system. I think the Cadillac system is the best that any I've seen, and I don't work for GM, I don't drive a Cadillac, but I do think that they are good, but they're not great. They're not great because as all of us know, you can have your face forward, you can have your eyes on the road, and if we remember this line about task unrelated thought, you can be in task unrelated thought and theoretically have your head in the right place and still not be there and still miss all kinds of problems coming up in front of you. And that's assuming if you have a good driver monitoring system. My favorite video about the Tesla driving monitoring system, which is a torque monitoring sensor, is that all it takes to defeat the driver monitoring system is an orange. And if you haven't seen these videos, there's a ton of them on the internet. I really suggest you avail yourself of them because, and I'm sorry, I'm about to insult probably the majority of the people listening to me. This is a man thing. I have never seen a woman put a video up on YouTube talking about how she tricked her Tesla autopilot by an orange. So what we're seeing is we're seeing a lot of aggressive drivers who think it's cool and funny and cute, put oranges in to defeat the driver monitoring system, and it is the defeat of the driver monitoring system that can kill them. Now, in the cases of the 3 big accidents, the Banner, the Brown, and the Wang accident, we don't think that, I've never seen any evidence that there was any driver defeat monitoring system. But of course, it's just a matter of time before somebody is doing something dumb. And I think what we're seeing here is a driver monitoring system that can be defeated this easily. And also, we testing, and I'm going to show you a picture from some of our testing soon. Oh my gosh, this thing takes 30 seconds between alarms to warn you to get your hands back on road. 30 seconds driving, that is an eternity. A lot of bad things happen. I read the Banner case recently. I think his hands were off the steering wheel for only like 7 or 8 seconds, and then something really bad happened to him. So I think this idea of how often people need to be brought back in the loop is an issue. So if we look at my recipe, definitely there's inappropriate role allocation, but it's at the driver monitoring system as opposed to the actual autopilot, which I also think is a problem, and we'll talk about that in a second. But Tesla is not doing enough testing. They have a financial imperative. They want to keep that driver monitoring system as a torque monitoring system because it's cheap. They do not want to integrate the more expensive head or eye tracking system. And of course, I've already said, we've got a ton of hubris there that's driving this. So let's talk about the future. So I recently wrote a paper, and you can read this on my website, that adapted the SRKE framework, and now I've put it into context of driving, right? Where you have to drive, keep the car on the road, stop signs are like rules and procedures. And then I love this, the expert base, I think there's some intersection somewhere, yes, that is actually real. I don't think there's a driverless car today that could get itself out of that problem on the bottom right. And so we have to start thinking about how are we going to fill in what I call top-down reasoning. That's when humans do abstract thought and mental simulations to get themselves out of tricky situations that don't match the world that the car thinks it should be in. So let me give you a couple of examples of what we're up against, and this is where the lack of effective skill-based reasoning is going to clash with knowledge-based reasoning. So this is from Toyota Research Institute. I work with them occasionally, and they gave me these pictures to show because they're very worried about what the future holds. So this is in Cambridge. This is a car that stopped at an intersection, and it couldn't figure out what was happening, and it just stopped, and it wouldn't go. And so they went back to the lab after it was over, and they pulled the tapes, and then they looked at the perception system, and this is what the car saw. So let's go back one more time so you understand. So you are seeing just a truck. In fact, when I showed you this picture, you're like moving truck in crowded Boston. Yep, that's all it is. But instead, the perception system sees 2 trucks, a bus, a gigantic person about to attack it, a fence, some poles, and it got everything else right, but it couldn't move because it had all of these guesses, these wrong guesses, right? So this is when you've got bad skill-based reasoning, which happens quite a bit with deep learning. Then what happens is if the system doesn't know it's got underlying bad data, then the judgment and knowledge-based reasoning that comes after it is going to be deeply flawed, which is how we see these accidents come about. But, you know, Toyota's not the only one. Bosch has a similar problem. These cars, these perception systems in these cars, the vision systems, they reason at the pixel layer. They reason, they see patterns in the world, and then they abstract those patterns. They have no ability to have and bring in abstract top-down reasoning. You know, you see two cars, but the vision system sees two cars, three bikes, two of which are driverless bikes, right? So the system can't even infer that there might be a person on the other two bicycles because the systems they don't reason the way that humans reason. So I call this the perception long pole in the tent. We are never going to get to driverless cars, truly effective driverless cars, especially at highway speeds, until we can solve that top-down reasoning problem. Oh, but wait, there's more. There's more problems. If you haven't seen this, this is a good paper worth reading. This is a way that some researchers developed a way to put these stickers on this stop sign, and they were able to defeat the convolutional neural net algorithm underpinning the vision system. It would be a car visioning system to see not the stop sign, but instead to see a speed limit 45-mile-per-hour sign. So this is starting to get real because this is actually something we call passive hacking. So if you know what you're doing with convolutional neural nets, and a lot of people do, then it is possible you could start passively modifying the environment and making changes that could lead to serious problems. And if you haven't seen this one, this is the latest example of that. So some researchers went out and they tricked a Tesla who was driving in a 35-mile-an-hour area. They just extended the center part of the 3 out. Now, if you had seen this sign, you would say, oh, some kids have been fooling around with that, like, or some DOT really screwed that up. That 35-mile-an-hour side looks crazy. But it was enough to trick the Tesla into seeing 85 and accelerating to 85. And so what's disturbing about that is that there's actually no other rules inside the system that make it understand that, hey, you know what? If you're in a 35-mile-per-hour area, you're probably in some kind of residential area, at least some kind of urban area. Why would you ever accelerate to 85 miles an hour in that area? But it shows me that there's some immaturity in the rules that Tesla is using, and it obviously highlights the problems that the vision system is having. So a couple more slides. So how can we address these shortcomings? You know, this is my formula. So, you know, each of those you, in theory, except maybe the last one you can address. I think people need to pay attention to this issue of inappropriate role allocation. It needs to be in people's minds. Are we asking the system, the computer-based system, to do too much? And or are we asking the human to do too much? It works both ways. We need to understand that there is an effective balance. And of course, I'm going to tell you that I think a collaborative arrangement is almost always the best case because I'm in the humans and autonomy laboratory, not humans or autonomy laboratory. But I do think it's important that we understand that we need to go back to basics. We need to go back to basic requirements, basic functions, and make sure that we're doing the right allocation. More testing. I love that. I hear COVID-19. That's all we want to talk about with testing. I would like to put a little PS also for autonomous cars. Testing. We need to do a lot more testing. We need to come up with testing strategies, and I'm going to come back to that. You know, perceived financial imperative. I mean, that's outside the bounds of anything government agencies can do, but government agencies can go back and look at that regulatory oversight issue. The issues with Tesla are serious. I do believe that autopilot should be turned off. I think it's so dangerous. It's encouraging so many behaviors, and we'll go ahead and skip to why do I think that way? Well, in my own research, the Department of Transportation is funding me to look at how to start thinking about certification testing for these automated / autonomous systems. And so this is, I'm just showing you, this is basically a state model that we're developing of drivers, the driver assist system, the environment, the sensors in the car. We're trying to account for all of this to start identifying weaknesses. And we've gone to the road to start doing some testing. So this is some testing we did at a closed track in Garysburg, North Carolina. And sorry, let me see if I can, well, my little control for my car, it won't go. Well, I'll send you this movie later if you want to see it, but what you'll see is that the car it veers off the road in a lane departure test that is in a very scary way. And the thing that what we did is we actually went and rented several Teslas. We didn't buy them. We don't have that kind of money. DOT didn't give me that much money. But we rented a bunch of Teslas, all the same year, all the same model. And then we took them out to this track and we put them in a scenario where they were just slightly headed to the edge of a road. And that's what that last video would have shown you. I think this is really compelling that out of these are 3 cars and each car had 10 trials. When you look at all the trials, almost half would have run off the road, half. And these are very slight nudges towards the edge of the road, right? So almost half, the driver got no alert. In a few more, they got an alarm. And then if you'll see in 5 out of 30 cases, they actually got the driver assist that you're supposed to get. So there's a lot of variation between individual cars. You can see that in the graph. There's a lot of variation, obviously, across the cars. So in 30 almost identical scenarios, each of these cars individually and as a whole performed very differently. And so if you've got this kind of variation happening across one car's sensors that are in theory supposed to keep you safe and also engage you to get your hands, but yes, I'm sorry, and these were all on autopilot. You know, half the time, after I saw this, I thought, man, I'm surprised we're not seeing more accidents than we are seeing. And in fact, my poor graduate student is now so afraid of a Tesla. He thought it was really cool before we started this set of tests. Now he's definitely not going to buy one. So not good for Tesla. All right. So with that, I'll take questions.
Thank you, Missy. Mike Hughes will be moderating the questions and talk about how we'll do that. But I can tell you that was a fascinating presentation, and I know that I know how difficult it is to lecture in a virtual environment. But I can tell that people are engaged because we're getting questions through the chat and through email that are sending to me. Anyway, thank you very, very, very much. Mike, I'm going to turn it over to you so you can explain how we'll do the Q&A.
Very good. Excellent job. So we'll have everybody can have the opportunity to ask questions directly to Dr. Cummings through their computers or their iPhones. We did get one question in the chat. It was from Brian Dennis. And Brian asked, can the cars with the computers, can they be hacked?
Oh, yes. Oh, yes. There have been many cases of cars being hacked externally. You know, I don't mean to overblow it, but I mean, it's basically trivial to GPS hack a system. It's a serious problem. GPS signals are incredibly vulnerable, so it's not very hard at all for you know, some ne'er-do-well to get in there and GPS hack. It's a little bit more involved if you want to hack into the car and start controlling throttle. That's been done. Just go to YouTube and you can see many instances of that happening. But I think, you know, and I think those are real issues today that we really have to address today. But I'm also very concerned about the increase in passive hacking, like I showed you through those signs. So this idea of passive hacking, convolutional neural nets, this is brand new stuff. I mean, this has only been around now for a couple of years that we as researchers in academia have started to even realize that this is possible. And what makes me very uncomfortable about this is if academics are still surprising ourselves almost on a daily basis with what the vulnerabilities are to this system, then that's probably not a technology we should be putting out for operational deployment.
Very good, thank you. So if anyone else wants to comment, they can use the hand feature and then kind of speak the comment as well. You can use the chat, but we encourage everybody to, to speak their comment if they can. Just use the hand feature and I'll go ahead and call on you. There is another question. It came from Michael, and Michael, I'm sorry, I don't know how to pronounce your last name, Hope. He said, thanks for the presentation, Dr. Cummings. Can you discuss the differences between rail and road further?
When you say the differences, I would say, do you mean the differences in approach to automating, the differences in regulating? I think there's a lot of differences. I would say, if I was going to make a guess, if you meant about the sense of automation, I think there's a historical perspective there about the regulatory agencies. I think and the commercial landscape. So right now, the reason that driverless cars have just exploded on the scene in the way they have is because people really sense their money to be made. Access to roads is everywhere. It's almost free. It's very cheap if it's not free. Access to rail is still really controlled by, like, the robber barons that I was talking about. So this is kind of the problem. We're seeing technology explode on the scene in driving because there's potential for big money to be made by non-traditional players. That's just not the case in rail. And indeed, I think until we can actually figure out, if I could get Elon Musk to start his crazy passion about something, I wish he would get involved in rail so that we could start to really look at that as a viable form of transportation for this country.
You're welcome to ask your questions orally. But so that everyone's not speaking over to everyone else, if you will, just raise your hand, which you can do on the ribbon going across your screen. Raise your hand, and then Mike will call on you. That way, we're not stepping all over each other. Brian Dennis, you can, if you want to, you can turn your screen or your camera off. We're seeing your backdrop, but not seeing you. But while we're waiting for some questions, Missy, I've long referred to the SRK model of Rasmussen, and Julie Kang was nice enough to put up a slide, which is a website to a link to some of his work. Mm-hmm. But I've always known it as SRK. Did you add the E, or is that something? Okay.
Yeah. So I added the E, and I also weaved in the uncertainty component because, and not that, and he's, in his earlier work, he sort of gets at that, but I wanted to make that an explicit representation that, because uncertainty is the key behind autonomous systems. Whoever learns to deal with uncertainty in autonomous systems will win. It is really, really hard. To be perfectly honest, I don't see us being able to deal with the uncertainty monster well enough to have real driverless cars on the road in my lifetime. I just, unless we start seeing massive changes in sensor quality and new ways of trying to basically represent knowledge-based reasoning and expert-based reasoning and be able to bring that to bear at the right time, I just don't see it happening. Now, I do see, the news is not all bad. I think delivery cars who are going slow speed, maybe some slow speed shuttles, Las Vegas has one, there's a few around the country. The slower speed helps tremendously because it reduces the computational demand. And you could potentially augment the world with these slow speed shuttles with more sensors to give it a better picture of the environment. So it's not all bad news. I don't think all driverless cars are doomed. I think it is not possible, and not even going to be close to possible, for anyone on this on this meeting, virtual meeting, none of us will have the luxury of being able to order a driverless car and having it take us to Vegas.
Very good. Thank you, Dr. Cummings. We've got questions coming in both via chat and through the app. Chris Poland would like to give a question. Chris, you can turn your camera on and ask Dr. Cummings a question.
Hi, Missy. I'm Chris Poland. So, with the NTSB, specifically our Office of Highway Safety, we have some flexibility in choosing the crashes that we investigate. And as you talked about today, we've investigated several Tesla crashes involving autopilot. We investigated the Uber test automated vehicle and one of the automated slow speed shuttles. So based on your research, are there some areas that we should look at or some specific crash types that we should try to become more aware of to reveal some of the additional challenges associated with this step towards autonomy or the step towards some level of autonomous vehicles?
Yeah, great. I think that's a great question. So I think all the accidents that you've been investigating are the ones I would want you to investigate, but there's a whole nother class that's a lot harder to investigate, which I think is kind of there's a latent, huge underground problem, and that is people who think autopilot are still on, and then they're in a crash, and they say, I was on autopilot, and then it crashed. And then Tesla pulls the tapes and Tesla says, you weren't on autopilot, not our fault because you weren't on autopilot. So one of the things that we're seeing quite a bit of is people think the car's in autopilot. So they have this expectation that the car is performing, and autopilot will disengage. And this from this last round of testing, and I'll be sure that everyone there gets an invitation. We are going to release a very controversial paper that looks at the details of that testing. And that's one of the things we're focused on. It's like, well, how often did the alarm go off and you wouldn't really recognize either the chime isn't loud or autopilot will disengage itself and you will not know that it disengaged. And so I think that that is much harder though, because, right, so how do you know whether it was just the idiot driver or the driver really did, and how could you even start to pull the tapes to understand that there was an autopilot shut off? Me personally, if I got to run a testing investigation there, that's what I would do is I would start trying to get Tesla. I would look to see how often autopilot was engaged just prior to a crash, because I think that you'll see, if you look at enough crashes, that you would see some kind of common trend there.
Thanks so much. Yeah, that's feeding into some of the questions that we ask when we're first learning about some of these crashes. But it gives us definitely something to think about, because we do ask not only was a system engaged at the time of the crash, but was it engaged prior to the crash, and kind of that duration of time period between when it was potentially disengaged. So thank you. Appreciate it.
Mike, I'm going to jump in here just for a second. I want to thank Chris Poland for, we had scheduled Missy to speak last week. She was going to speak on the 13th in a live session. Well, of course, everything has changed over the last 10 weeks. And so we canceled her. Well, Chris Poland wrote me and said, Robert, whatever happened to Missy Cummings? We were hoping she would be here. And she said, so Chris suggested, wonder if she'd be willing to do it virtually. So Chris, thank you for the prompt. This has been and it's not over yet. We had over 140 attendees, which is the greatest number of people we've had for a speaker series. I'm I like to make sure that these things are exactly 1 hour long, and we're coming to that time. However, we do have several questions I see several hands raised, plus we've had some come in from the chat. So if you need to leave, we're hit the hour mark right now. If people need to leave, you certainly can, and we understand, but such great presentations, such great questions. I'd like to continue that. So Missy, if you're around, we'd like to continue this going. Okay, great. Mike, I turn it back over to you.
Very good. Thank you, Mr. Chairman. I've got this question. This came in from Jerome Cantrell. Jerome asks, do you have any suggestions on how to keep vehicle operators engaged while they are using driver assist systems?
Yes, this is a great question. I've spent many, many years thinking about it, looking at some early designs about how could you potentially, could you give people something to do? You know, is it better if they could be heads up touching something on a screen? Would that be better than nothing at all? You know, and then if you, so I, you know, I don't want to rule that out because I'm not all knowing, and somebody may be more clever than me that can come up with something in a way to keep drivers engaged. But I'll tell you, because I have a 12-year-old who will eventually be 16 years old, and what would I do for my own daughter? I actually think that is actually how you know when driverless cars are really ready, is if the developers of the driverless cars would put their own kids in there. So let me tell you what I'm going to do for my daughter. My daughter is getting the oldest Volvo I can possibly find. It's going to have no automation in it. Maybe cruise control, maybe not. I'm going to take her cell phone away. I'm going to put as much electronic tracking as I can in that car. And she's not going to have anybody else in the car with her until she's 30. No, I'm just kidding. But I think that I just think that we have to appreciate that anything more than cruise control, and I even think active cruise control may be too much. If there's anytime we feel like that we can give the driver something and we want to make their experience, we want to reduce their workload. I think there's two things going on, is that humans will tend to take too much advantage of that. But I also think there's something going on with the culture that we live in and cell phones and demand for technology and demand for mental stimulation. I think that we are fundamentally changing our brains. We cannot stand, and this is myself included, I can't stand not being in the know. I can't stand it if I'm not thinking about something. I cannot necessarily have my cell phone, but I have this whole list of topics. When I go into a meeting that I know is going to be boring, I literally make a list of topics of task unrelated thought, problems I'm going to solve in my head while I'm at this super boring meeting, right? That's because I just can't stand not having any mental stimulation. I think I am an average person in America. And so I think that we are just doomed. If the more driver assist that we put in that just is sub real autopilot, the worse this is going to get, because it's just going to lull people into a false sense of security. I think complacency is going to go way up. And I know that's not a sexy answer, and that's not an answer people want to hear. That they don't want to hear the answer of, actually, you need to just keep your head in the game. And by keeping your head in the game, you need to have not that many whiz-bang gadgets and widgets. And the car companies hate that. But it is what it is. Some driver monitoring, certainly camera-based driver monitoring can help with that. But I do think we need to ask ourselves, what are we trying to do with putting the bells and whistles in this car? And until we can actually get to full self-driving, we may actually be making the problem worse as opposed to better.
All right. Thank you, Dr. Cummings, for that answer. I'm going back and forth between the chat and those who had their hands up. Doug Brazy, I know you had your hand up for about 10 minutes. You put it down. If you're still on, you're more than welcome to chime in with your question. Doug, go ahead.
Can you hear me?
Yes.
Great. Thank you, Doctor. That was just an absolutely wonderful presentation. I learned a lot, and I really enjoyed how it was spanned across many of the modes that we investigate. I lowered my hand because you just about answered my question in the last go-around with, are there any bright spots with driver assist and adaptive cruise control statistically for avoiding accidents caused by inattention? Is there a bright spot in using some of those technologies or not?
Yeah, I think that's a great question. It's interesting because for the longest time, Toyota had this concept called the Guardian concept, and I was a big fan of that. So I am a fan of taking these technologies and helping the driver, maybe in a way that I call putting bumper guards around the car. You know, like the virtual rumble strips, I really am, I like just regular rumble strips, and I love the virtual rumble strips. I am less thrilled about the automated lane steering. I think one of the next, this goes back to the question I asked earlier, like what other accidents should you be investigating? I'll tell you one that nearly killed me the other day is a rental car. Like I was in a rental car that had automated lane steering and I didn't know, you know, nobody told me that the rental car had this. I'm on the road and I made a sharp move into another lane because I'm not a good driver. And so the car countered that. And, you know, I mean, it was just like instant response. Like, so immediately I find myself fighting with the rental car. And I've had it do that. I've had it accelerate on me unexpectedly because somehow I'd activated some kind of cruise control mechanism, which again, I didn't know that was there. And I'm no dummy, right? So, and I do know that there's a larger problem in America where people need to understand what the technologies are in the system. I do think automated emergency braking, I think that should be mandatory on every car. This is a problem, though, of course, of driverless cars, as we saw in the Tempe accident, that there's often a war between the automated emergency braking and the sensors because it causes a jerky ride. So I think that there's more engineering that needs, I think the problem is solvable, by the way. I just think more engineering needs to be done in that particular case. So I am a fan of keeping the driver from doing dumb things and helping the driver avoid accidents. At the same time, I think we still have so much to do in terms of the human interface to make sure that the human driver is aware of what is happening and has the ability to either turn it off or at least understand what is happening in the moment.
Super, thank you. We've done a number of accident investigations where pilots are fighting autopilots unknowingly. So that's a very interesting point, I think, in all modes. Thank you so much. I really enjoyed your presentation.
Thank you.
All right, we'll keep going with the questions. We're going back and forth from the hands up to the chat. We'll go to a chat. This is from John O'Callahan. He says, thanks for the presentation. I heard that you say that eventually airplanes, at least, will be 100% automated. With perhaps only a babysitter on board. What barriers still need to be overcome for this to happen, and how long do you think it will take?
Yeah, it's a great question because it's one like, you know, go to an aviation conference and all the old rusty pilots are around the bar saying, oh, that'll never happen. Planes can't do it. And I actually love the young upstarts in Silicon Valley that think they're going to have flying cars next week. We all know that's not going to happen. I think that, look, every modern commercial airliner, it's just a drone. I mean, it really can't. The only reason that planes don't automatically take off right now is that function has yet to be certified by the FAA. But if you know, drones that are as big as commercial airliners are taking themselves off around the world, you know, it's just a matter of time before that happens. And in fact, the takeoff period, we did a study and went and interviewed pilots from all around the country. And if you're in an Airbus, you're only touching the stick 3.5 minutes out of a flight, any flight. And if you're on a Boeing, you're only touching the stick 7 minutes. And it's all in the takeoff stage. And so, look, we're practically there. I think on the SRKE diagram that flying is so much easier of an environment to work in instead of driving, because when you're flying, there's not 50 other idiots flying just inches from you, right? It's an obstacle density problem. And it's the fact that we've got more mature navigation and control technologies and you know, ADSB is really important. And we need, because of the GPS vulnerabilities, we need to move along. We need to get some more assured navigation technologies coming in before we can actually go fully automated. But, and I am, if we really pushed it, and I do believe that in other countries, maybe prior to, maybe the COVID thing is going to extend this out. I think you're going to starting to see fully automated cargo very soon, within less than 10 years. The passenger issue is a different case. I mean, most of you probably know that NASA has been working for a long time to go to SPO, single piloted operations. You know, the airlines can't wait to get 2 out, or to get 1 person out and go down to 1. So I think that there will be a phase that we go through where there's just 1 pilot in a cockpit. And then there'll probably be a phase of optionally piloted. I think cargo operations are going to happen for a long time before we agree that maybe SPO with the person not really engaged in the actual flying will happen. But I also don't ever see a time that we never have a pilot on board. That pilot is going to be someone like Captain Kirk on Star Trek. I mean, he or she's the captain, but it's really there for the crew management, not for the actual operation of the aircraft itself. But you know, we still have some gaps in our functional domains, like the bird strike, like in emergencies. So right now, emergencies are still the domain where you need judgment, knowledge-based and expert-based reasoning. And so we won't ever, for cargo aircraft, we really won't ever be able to get exactly to that point until we get that solved. The difference is, for cargo aircraft, we're willing to take more risks. We're not willing to do that with people on board. But I don't think we'll ever have a plane where there's no pilot on board. Somebody will always be there. He or she will be called the pilot.
All right. Thank you for that thorough response. There's a couple of people who put their hands down, but we've got Dennis Collins. Dennis, you have your hand up. Would you like to ask Dr. Cummings a question?
Actually, I just have more of a comment. The first being, thank you for the presentation. Enjoyed it very much. And second being that if you didn't know, or as Chris said, that shuttle driving around downtown Los Angeles had a crash 2 hours after it started, and we actually sent a team out. And the big lesson from that was the vehicle did exactly what it was programmed to do. It just couldn't figure out that if a truck was backing up, it was coming.
That's one of my favorites, actually. I love that story because it's a great example of the design implementation going bad.
And an anecdotal story from that investigation, we rode on the shuttle and it stopped at a stop sign like it was programmed to do, and there was somebody at the other side, so it waited. The gentleman behind us was rather impatient, went around us, laid on his horn, ran the stop sign, and went on his merry way. And I think that's one of our big issues too, is not so much what the vehicle is going to do, but what everyone else around it is going to do.
I agree. I agree.
But enjoyed your presentation very much. Thank you.
Thank you.
All right, thank you. We've got a question from the chat line. This is from Yuzi Yang. And Yuzi, I'm sorry if I mispronounced your name. She had a couple of questions. One about Hyperloop. Do you have any questions, any comments, Doctor, about Hyperloop in general? And then secondly, do you see more software system level or sensor hardware level improvement in the automating required? I'm not sure if that came through.
I think so. I'll answer what I think is, and then ask me again if I didn't get that right. All right, now, and remind me what the first question was.
The first question was about Hyperloop. Do you have any?
Oh, Hyperloop, right.
Hyperloop, yeah.
Okay, can I do the Judge Judy eye roll any bigger? Ooh, I am so old. This is how you know when you're old. I'm so old that I actually know, I've been in and around the research game long enough to know that the Hyperloop idea, this is like its third instantiation. This is like the third time somebody's got that crazy idea and then tried to roll with it. Like, it's just not going to happen. It's the science is there, meaning we know how to do it. It is just so cost prohibitive that it's not going to happen. And so the thing that drives me crazy about Hyperloop is I really love SpaceX, and I want Elon to focus on SpaceX, and I want him to get rid of Hyperloop because it's just a distraction. It's not going to work because it's too expensive. So on the question about software, let me go back and say, I think the number one problem for all areas, this includes transportation, but it also includes medical systems, financial systems, not financial systems, manufacturing systems, is the hardware software interface. So we know how to build a thing like a plane, and we actually know how to program a phone pretty well. But where we're having a problem is when the software interfaces with the hardware. And the Boeing 737 MAX is a great example of, there was some software that was developed in isolation and the hardware was developed by another team. And then there's this integration layer that's got to happen, and not enough time was spent on that integration layer. There's actually very, very few engineers that can do both. And this is where we're having a huge talent. It's not even a talent drain. It's just, we're just not putting out enough people in the world that can work at the interface between hardware and software. And so I'm going to put the blame back on academia now and tell you, the bottom line is academia must change. Academia has got to understand that pretty much software is a tool that should be in every engineer's toolbox. You know, maybe some people will focus more exclusively on software, maybe some will more on hardware, but we need to start thinking of software development as a core element that needs to be taught for every person of engineering who is definitely going to touch any system that works at that hardware software interface.
All right, thank you so much. We've got a couple of questions if you're willing to answer some more. Doctor?
So listen, I don't have to race over to Washington National to grab a flight. So you've saved me a lot in travel time, so it's fine.
Yeah, let's take 2 more questions. I know that there really are more questions than that, but I think at some point we've got to give you a break. I mean, really, this is fascinating, and there is a lot of interest. So let's take 2 questions.
Very good. Okay. Dr. Julie Kang says, Dr. Cummings, thank you so much for your continued works in transportation. Could you provide us with an update with your research and the communicating intent of the operators of the ADS/AV to pedestrians?
Well, you're like the only person that's reading that, so I really appreciate Julie. Was that Julie? Julie, I really appreciate you calling that out. We have done the research about the pedestrians, and basically we show that 20% of pedestrians are making really dangerous decisions, and that's pretty consistent without technology. I actually put a proposal in front of the National Science Foundation I had a team of landscape architects and a team of engineers, and we were going to get together and talk about the redesign of pedestrian crossings to try to figure out how you could actually design affordances into the environment to get pedestrians from making these bad decisions. It sounds like, I tell you, it sounds like a great idea, and NSF rejected my proposal. So, I'm so mad at NSF, but I definitely think there's a lot more that can be done about that in terms of trying to get pedestrians to be better about their behavior. And for those of you who haven't read the study, this is pedestrians who are looking at their phones crossing the street. There's so much badness going on out there. And we did a formal study to show what everybody suspected, but now we've got the formal evidence that 20% of people are making bad decisions if they're looking at their phones. More broadly, though, when we come back to how this works with driverless cars, pedestrians are a huge problem. They are not, you are still very much at a risk if you're a pedestrian in an environment with driverless cars. And this is, in fact, where the slow speed shuttles, they worry about this, and they should worry about it, because this is still a problem. I think it's a little bit easier for the slow speed shuttles to try to detect pedestrians, but there's still the problem of the reveal, like, somebody coming out from behind a truck parked on the side of the road at the last second. So I still think that there's a lot to be done. We could argue there's maybe some other sensors and mirrors and things you could put in the environment to try to get more information in the world. But until we do that, it's still going to be a big problem for these cars.
All righty. And we do have time for one more question. I do want to acknowledge those whose questions won't be answered. Robert Aceta, Raphael, Marshall, Joseph, Gregor, and Ivan Chung. There's some questions in the chat, and Dr. Cummings, I'll send those to you offline, but since we've got time for one more question, we've got Denise Davella. She says, do you consider cruise control to increase the risk of a crash as well?
Okay, let's be clear. I love cruise control. I actually like to pull a trailer. So I desperately need cruise control when I'm driving. I really, really appreciate cruise control. So I think cruise control is good. I said adaptive cruise control that's about the most automation that I would feel comfortable supporting in a car. To me, adaptive cruise control, it's right at that cusp, because it still lulls some people, not everyone, but it can lull some people into, oh, let me just check that phone one more time, or it's just right there in my phone, right? The phones are the bane of our existence in cars right now, but if it wasn't the phone, it would be something else. So, cruise control, thumbs up, definitely thumbs up. Adaptive cruise control, maybe the, having a little bit more interaction with the human. Yeah, so I'm good with that.
Okay, sir, I'll just say a few things. There is a survey link in the chat. I've just posted it again, so you don't have to scroll back up. And then please give us your feedback. We've got great feedback from last week's events. I encourage people to continue to fill out the survey so we can keep making improvements. And sir, I'll have you have the last word.
Thank you. By the way, I don't know, Missy, you probably can't see the chat, but Yushi Yang did write back. Thank you for the answer. Well, actually, it went away. Thank you so much for your great presentation and the answer that you just gave. That was 3 questions ago, but I do understand the complexity of presenting in a virtual environment, but it's been very well received. As far as having a 12-year-old, when I joined the board, my daughter was 12. Unfortunately, in about 6 weeks, she'll turn 26. So it goes very quickly. But anybody who was at the board when I came there knew how concerned I was with teen driving. My daughter learned how to drive in an old Volvo. However, when she turned 16, she refused to drive it, so I had to buy her another car. That Volvo is still in my driveway. If you'd like it, it's 25 years. Yeah, it's 25 years old. It just needs a battery. Anyway, PTC, he made some great, so many of the things that you talked about were exactly aligned with our positions here at the NTSB. And, your positive train control, we've certainly been calling for that for a number of years, as you know. I'll close it out. I was just looking over my notes. We always give our speaker series speakers a token of our appreciation. And so I'd like to give you this right here. So thank you. It looks actually nothing like this. This is something that somebody gave me for something, but we will mail you an official appreciation of being the NTSB Speaker Series. This was wonderful. I really want to thank you not only for presenting, for coming to join us. We do want you to come once we get past the crisis. We want you to come back and we'll introduce you around and show you around. But so not only do I want to thank you for speaking, but I want to thank you for the great work that you are doing in this very important area. So thank you all. We'll see you later. And Missy, thanks so much. I'll call you in just a moment. Yeah, thanks.
Okay, thank you. Bye-bye.